So here we've got a question about blood disorders across the world. In the first part, part A, it spells out you have to use a binomial distribution, which you need to remember is S1 word, but it crops up quite a lot in S2. For a binomial distribution for x, you need to set up an n and a p. So your first job would be to read through the first paragraph and decide on sensible values for those. So maybe you'd like to do that before carrying on. Okay, n is the number of trials, and the thing that's been repeated is 25 villagers. We're taking 25 trials, and the probability of having the disorder is 70% or 0.7. So your first thought might be to let n equal 25 and p equal 0.7. But if you do it that way, then you'll discover that these are not in the tables. And the best way to get the probability of more than 15 out of 25 in having the blood disorder, that's a lot of separate probabilities to add together. So you need to use the trick for using the tables where instead of using a p of 0.7, you use a p of 0.3. And the way to achieve that is, instead of thinking about the number of people who have the blood disorder, you need to let x be the number without the disorder, because that's what has a probability of 0.3. Okay, once you've done that and you set up the distribution of x, you then need to think about more than 15 of the 25 having the blood disorder. You need to say how many of the 25 don't have the blood disorder, and that's the probability you need to get looking at tables. And that's how you do part A. Moving on to part B, B.E1, we've got a Poisson distribution with a mean of 2.6, and we need the probability that at most 5 people have this blood disorder. You do have to check that the number of people to which the mean applies is the number of people that we're looking at, but that's the case. So it's a simple Poisson distribution with the given mean, and the probability of at most 5 people you should be able to get using the tables. Going on to .E2, again we've got a Poisson distribution. We are after the probability of exactly 10 people having the blood disorder. So we're going to be using the formula from page 11 of your formula book. But now we do have to watch out. The mean is 49 people per million, but we're looking at a population of 100,000. So the number of people in that 100,000 having the blood disorder will have a different mean. So you need to set up a Poisson distribution with a different mean based on the 49 per million being scaled down to this population. Then finally, we've got T, which is the total number of people in the 2 selected towns. So we're merging the 2 towns into one. We've got a Poisson distribution in part B1 for the first town, another Poisson distribution. When you add together 2 Poisson distributions, then as long as they're independent, then the total of the 2 Poisson distributions is another Poisson distribution, from which you're going to set up a mean based on the 2 previous means, and you're going to work out the probability of t being greater than 16, again using tables. And that's how you tackle that question.